Hello, Integrated Math 1. Welcome to lesson 5.2.2b. We're on day 2 of our translations as functions. So we left off last time learning how to write our translations as functions, right? Just to remind you, you are going to want, maybe a compass and a straight edge and a pencil and a few other little things. That's okay. But if we come over here, back to page 72, I know we already did this, but I just want to take another look at it. We said that writing a translation is a function, a translation function. We use a capital T for translation. The little subscript tells us, hey, this is how far you're going, and this is the direction you should be going. And then, of course, we put in what it is we're translating. This is our input, and this is what we get out of it, our output. So, like when we did the little triangles, and I was like, again, sorry, I'm going to label things here. I want my pen. I want my pen. So I've got S prime, Q prime, R prime. So when we have this, we said that, okay, I'm doing a translation, capital T. The distance I'm going is from S to S prime. So I'm going to put a little S to S prime. Triangle, the input was triangle SQR. And when I translated it from S to S prime, I got out of it triangle S prime, Q prime, R prime. So last time we were focusing on that notation and how to write it. We have an example. This is how we write it, all that good stuff. But now we're going to go the other direction. Now I'm giving you the function, the translation function. I can say it. I'm going to give you the translation function, and I want you to actually do the translation. So this is over on page 73. This is number 7. It's got a part A and a part B. You can see I have my original figure. They even give me a little point to kind of help me out a little bit. Gave me a lovely point. And we're going to translate from A to B. So from A to B. And remember, not only is this a distance, which it is, it's also a direction. So you're going to take the point and you're going to translate it, but you're translating the whole sun with you. So I would recommend translating point P and then going ahead and trying to draw the sun around that. I'm not a great artist. You guys will probably do better with this than me, which we'll see in a second. Go ahead and hit pause, do the translation, and then hit play when you're ready to check your work. Well, we did say the input didn't have to be numbers last time, right? So I guess we're just taking that to the extreme. Let me bring out my camera and hope it works okay. We've had problems with that today. Oh, look, it's working just fine, just fine. I'm going to go ahead and use my straight edge, and I'm like, okay, we're going this distance, and I'm going to be like, do, 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 do. I do want to keep things parallel. This isn't going to be perfect, but I'm going to go ahead and make a whole bunch of parallel lines. I'm going to do it actually for a bunch of the points on my sun. I think that'll make it easier if I do that, right? If I'm like, there's another point, and maybe here's another point, right? I'm just going to do a couple of these. I'm just going to make a whole bunch of, oh, they're supposed to be dashed lines. I'm doing a bad job. That's a terrible dashed line. I'm going to go ahead and take my compass here. I love the compass. And I'm going to measure point to pencil. I'm just going to measure point to pencil. And if I do that, then I can come up here and I'm going to turn my page a little bit here. You can turn your book as well. And I'm going to make a little mark. And I'm going to come over here and I'm going to make another little mark. I'm going to come over here and make another little mark. And I'll be like, okay, well, this is now P prime. And I can see this would be the other side. This would be the guy on the bottom. And so I'm not a great artist. Please remember that. Please show me some grace. I'm not a good artist, but I got another one up here. You could do this for every single one of these if you wanted to, but it just helps me make my sun. And then I have my little woo, sun. Not the best drawing I've ever done. Not the worst either, though. So, kudos, credit to me. I'll take it. That's fine. And I translated my son. Here's the digital one. It's kind of prettier, but I'm pretty proud of mine. I did okay. All right, I want you to do it again. I want you to do it again now for the moon. This one's trickier, but I believe in you. You can do this. You can do this. And I apologize. That looks like it says CM. That should actually, in your book, it should say L prime M. I'm not sure why it says CM. That's weird. Go ahead and hit pause to work this out, and then hit play when you're ready to check your work. Did this one feel trickier? Maybe it did. I don't know. Hang on a minute. Oh, well, my camera. I want my camera. Pop. All right, I'm going to the moon. I did go to the sun. Now I'm going to the moon. It was a little too hot on the sun for my tastes. So we're saying the distance is from L to M, L prime to M, pardon me. So I'm going to go ahead and I'm going to measure some distance. I'm going to make a line here for P just to kind of help me out. I'm going to use P. I'm going to make a line. This isn't perfect, but I'm going to kind of make a line kind of parallel. I'm just making a dashed line. I'm going to do it again for this point up here. I feel like I should do it for this point too. If I'm going to make a moon, and I'm going to kind of make a parallel line and a parallel line. I don't know how long it needs to be, so we're just kind of estimating it. Maybe I didn't make that one long enough. Now I'm paranoid. All right, we said we're going from L prime to M. So L prime, stabby side, to M, pointy side. And that's how far we're going. It's pretty far. I'm going to put my stabby guy on P and make a mark. I'm going to put my stabby guy up here and make a mark. I'm even going to put my stabby guy on M and make a mark because, why not? So here's the top of my moon and the bottom of my moon. We shouldn't be mooning people, and yet here we are. And I'm going to be like, and there's my moon. Okay, that was worse than my sun. Look how cute my sun is compared to my sad little moon. It's not the best. Shade it in. Okay. Yours probably looks better than mine. That's not the best moon I've ever done. My sun was so adorable too. Oh, well. That's okay. Hopefully you got something that looked like this. It definitely got a little weird, but that's okay. We still love it. So this is going to help you do a bunch of your homework problems now that you kind of have an idea of how this works and how we do this. And hopefully this is also giving you a better feel for this notation and how it works, right? So can you explain real quick? Because you notice I kept saying, I'm going to make a line parallel. I'm going to make a line parallel. I kept doing that, right? Can you explain why we can use those parallel lines when describing translations? Hit pause, write it down, hit play, check your work. So I use those parallel lines because they help me determine like the horizontal and vertical aspect of my translations, right? They help preserve that rise over run. They help preserve the direction I'm moving in. So you can phrase it however you like. Now there is one last thing. There is a key term that we kind of glanced over next time, but we need to dig into it a little bit deeper right now. So the key term was isometry. Remember we said, and I have it highlighted here for you, back on page 72, we said an isometry is a rigid motion transformation, and this is important, that preserves size and shape. This is important. Let's go over to page 74. So we were talking about bow tie and how we had this cute little logo and it was going to like zoom, zoom, zoom in on our website. And we were like, it's going to be so cool. So when users click on the menu of bow tie, copies of 3 triangles will move from the corners and top of the web page to the center to form the background of the word menu, right? So we've got this guy at the top, we've got these triangles at on the bottom in the corners there. And what'll happen is somebody clicks on menu, they'll be like, woo, and they'll make this little like menu guy in the middle, right? So cute. My first question for you, are the triangles all congruent? Explain why or why not. Hit pause, jot down your thoughts, hit play to check your work. You can use your compass to check if you like, right? You can like measure those distances a little bit. all of the triangles are congruent. All the triangles in the three originals are congruent, and they're all translated along parallel lines. So their translations are rigid motions. These preserve size and shape, which means it's an isometry. Maybe we should even write that down. This is an isometry. We kept the size, we kept the shape. When these triangles zoomed over to wherever they were supposed to be, they kept their size and their shape. Now, the owner of Bowtie is thinking about using smaller triangles on the sides of the menu web page. She still wants the triangles to move and merge to form that background triangle menu, right? We kept the same size and we just moved and merged them, right? They came over like, woo, menu. But now she wants to do some smaller triangles along the sides of the menu page. Would these transformations, these smaller triangles, would they be isometries? And demonstrate or explain why or why not. Hit pause, jot down your thoughts, hit play to check your work. If the new triangles are smaller, we're not preserving the size, are we? We said to be an isometry, you had to preserve the size and shape. But if I'm shrinking my triangles and making them smaller, they're not isometries anymore. So the transformations are not isometries because the transformed figures have longer sides than the original figures. Yeah, we're changing the size. It's not an isometry anymore. So with this in mind, over on page 76, can you just make a few quick notes? Can you describe how to distinguish between an isometry and a transformation that is not an isometry? Just jot down your thoughts, hit pause, write it down, hit play to check your stuff. So I just made a few notes. I said an isometry is a transformation that preserves both size and shape. And I even wrote an example. I said a translation along parallel lines is an example of an isometry. It doesn't change size, it doesn't change shape. To distinguish, I said a transformation that's not an isometry does not preserve size and shape. So for an example, I said dilation. I don't know if you're aware, dilations are the ones where they grow or they shrink. A dilation and a translation along non-parallel lines, those are examples of transformations that are not isometries. So if I do a dilation where it grows or it shrinks, it's not an isometry anymore. I hope this gets into your head what an isometry is. Sounds like we're on the right track. I hope so. If not, come talk to me. You know I'm here to answer your questions and help you out. I'll be around, and I'll see you soon. Bye.